So first of all, let me introduce myself. My name is Arsanana Amalina, and I'm going to talk about type of function. There are injective, surjective, and bijective function. So before we are going to talk about the main topic, we must know about the function itself. So before the function, we must know about the relation. Relation in math define the relationship between set of values of ordered pairs. All the values that go into a function are called the domain, and the output values are called the range. While the function is a relation from a set of inputs to a set of possible ranges where its domain is related to exactly one output or range. And here's the definition of function. So let A and B be non-empty sets. A function f from set A to set B is an assignment of exactly one element of set B to its element of set A. We write f of A equal to B if B is the unique element of set B assigned by the function f to the element A of set A. If f is a function from set A to set B, we write it like this. So the function f is mapped the set A to the set B. And here is one of the example of a function. The function is f of x equal to 2x plus 1, where set A, this is the domain of the function that can replace the variable x in order to get the range value of it. And in the set B, all elements of set B are the codomain, and set B also contains range or image the set A to set B. So the range is 3, 5, 7, and 9 in this problem or in this case. Next, we are going to talk about type of function. There's injective, surjective, and bijective function. In injective function, its of element domain has unique and distinct range. The element of codomain cannot have more than one partner, but it can be single or doesn't have partner from the domain. While in surjective, the element of codomain must have at least one partner from domain, and every element of codomain has one or more partner. And in the bijective function is a function that injective and also surjective. So an injective, the codomain cannot have more than one partner, but it can be single or doesn't have partner. And while in the surjective, the codomain must have at least one partner, so it can be one or more partner of codomain. And this is kind of like the opposite from the codomain. Yeah. Next, in the injective function, this is the definition. A function f is said to be one-to-one or an injection if and only if f of a equal to f of b implies that a equal to b for all a and b in the domain of f. And by the definition, we can have the contrapositive of it, that f of a is not equal to f of b whenever a is not equal to b. So this is the definition, and this is the contrapositive of the definition. We can use whether the definition or the contrapositive of the definition to proving the function if it's injective or not. And this is the one of example injective function. So we can see that every codomain cannot have more than one partner of A, but element of codomain can be single or do not have partner. In this case, 4 is the element of the codomain that doesn't have partner. Next, we have surjective function. The definition of surjective function is a function f from A to B is called onto or a surjection if and only if for every element B that belongs to the set B, there is an element A that belongs in the set A with f of A equal to B. So it means that all the codomain are also ranged. And the surjective function, the codomain cannot be single or doesn't have partner, but it can have one or more partner with the element of A, right? In this case, we know that the one in the codomain have two partners in the set A. But in injective, this is not allowed, but it is fine in the surjective function. So that is the difference between the two of them. Next is bijective function, or we call it projection. And the definition is the function f is a one-to-one correspondence or a bijection if it is both one-to-one and onto. We also say that such a function is bijective. So the function is called bijection if it's injection and surjection. This is the example of the bijection function. We know that every element of domain have exactly one and distinct partner or image in the codomain or set Q in here. Next, determine the function. We are going to determine a function, whether it's injection, surjection, or bijection, with proofs and graph. So here's the function. We are going to determine whether the function is injection or not. It is a function f that maps the integers number z to the real number r, which f of x equal to x over 2. So if we want to get the graph of this function, we are going to use the basic method, which is substitution. We can find random value of x and then substitute the x values in the fx, so we can get the value of y of or fx. So example, here I choose 1, 2, and -2 to replace the variable x, and we're going to substitute the values of x in the fx this. So we can get the value of y in here, which is half, 1, and -1. And from x and y in here, we can get the ordered pairs that can be drawn in the graph, and we can connect the graph by connect the dot. So connect the 1, half and 2, 1 and -2, -1 in the graph in the Cartesian diagram. So here's are the drawing of the graph. I use the GeoGebra, and our function is f of x equal to x over 2, and this is the graph of it. We can use by the first method, which is the basic method, and connect the dot or the ordered pair in the Cartesian diagram. Next, we are going to prove that this function is injective function or not. So first of all, take any x1 and x2 in the domain where x1 not equal to x2. So here we are use the contrapositive to proving the function which is injection or not, because because x1 not equal to x2, we are going to substitute the value of this in the function, which is f of x equal to x over 2. And here we are going to substitute and we get this. And we must know that every integers, if it divided by 2, if it distinct integers divided by 2, so the output or the result of the operation is different too. So for example, we have 1 and 3 is integers, right? And we divide it by 2. It's obvious that the value of the result of the operation 1 divided by 2 and 3 divided by 2 is different. So in this case, we can conclude or we can assume that the output of this or the result of this operation is not the same because x1 and x2 are not equal, right? So we can conclude that f of x1 not equal to f of x2. By this, we can conclude this. So by this statement, we can conclude that for every x1, x2 in the domain where x1 not equal to x2 implies f of x1 not equal to f of x2. In other words, f is an injective function. So it's proven that this function is injection. Next, determine whether the function is surjection or not. We have the function f that maps the real number r to real number r, which f of x equal to x plus 1. So as the first case, same as the first case, we are going to the basic method, which is substitution, to draw the graph of this function by we going to choose any random value of x, and we gonna substitute the value of x in the fx equal to x plus 1. So we get this, and we get the ordered pair of x and y, and we are going to place it in the Cartesian diagram, and we are connect the other ordered pairs, so we can get line from that, from the ordered pairs of it. So here's the graph for the function x plus 1. Here's, if we substitute x equal to 0, we can get the y equal to 1. So we place the dot here, and if we want if we choose the x is minus 1, we can get the value of y is equal to 0. So we have ordered pairs minus 1, comma 0. So we place the ordered pair in here by the dot, and we are going to make a line with this. You can also make other ordered pairs. In, for example, you can can make this with 2, 3 in here for the pairs, and you can connect in the line. And I use the GeoGebra to make it easy or simplify the drawing of the graph. And next, we are going to determine whether the functions are surjection or not. So there's the proof. So we have a function f that maps real number r to real number r, which f of x equal to x plus 1. So by the definition, we know that we need to show that an arbitrary y in the codomain there is exists so from the definition we know that we need to show if there an arbitrary y in the codomain there must exist some of element in the domain that maps to the y itself. So we need to show that there is x in the domain that maps the y in the codomain, right? So in case to get to know the value of it, we are going to substitute the f of x equal to x plus 1 into this, and we get x equal to y minus 1. It means that an if we have an arbitrary element of y in the codomain, there is y minus 1 in the domain that maps to the y. So we are going to the proof. Take any y element of real number, which is codomain in this case. We are going to choose x equal to y minus 1 from this because we know this is maps to y, and we substitute in the function and we get the y. So we can conclude that fx equal to x plus 1 is a surjective function. And that's it for me. Thank you so much for the attention. Wassalamualaikum warahmatullahi wabarakatuh.